Cool. So the last video of this week is about discrete data, right? So I taught you in the last video how to calculate sample size with a continuous data, which is the one that have the scale. And now it's discrete. Discrete is just good or bad, right? So it's either good or bad. It's a classification. Okay. And also it's getting close to noon, and I'm very hungry. So let's get through that. Not that one. Discrete data. So the formula is similar but not the same. The difference here is to have to uh, calculate the standard deviation of discrete, and the way to calculate standard deviation of discrete is the problem is you only have a percentage, right? And you have to calculate the standard deviation of a percentage when you only have a percentage, right? So there's a way to calculate that, and you have it here. So it's 1.96. Again, it all depends on the confidence level. 1.96 is for 90% confidence level, divided by the error here, and then squared, and times p times 1 minus p. So what is that P about? P is the percentage, right? So that's basically the only data you have. How many were in that classification? How many bad products you have? How many quality problems you have? How many, people with this or that classification that you want to, okay? Or products with this classification that you want to. So n minimum simplest, we already know that, and that's p times 1 minus p, and p is the probability, okay, or the percentage. Let's take a look at this example. You have been asked by the benefits manager of your company to determine the proportion of workforce that use tobacco products on a daily basis. The company has 25,000 workers, and the manager believes that proportion is about 15%. So maybe that's a tobacco producing company, right? I work with tobacco actually manufacturers in Brazil quite a bit. How large of a random sample would you draw if you need 95% confidence levels and allow an error of plus or minus 2%? So remember that the error has to be in the same unit as the standard deviation, so it is already in percentage. So we just plug the numbers into the formula. 1.96 divided by 0.2, that's the allowed error, times p times 1 minus p. So p was 15%. 1 minus p is 85. That gives us 1,225, right? Because you have to round it up, because you cannot ask half of a person. And then you need to collect data about this amount of people so I can know how many of them actually smoke. This is the problem, right? And again, we're going to do a problem in class, but that's it for the data collection. Now you have everything, you can plan it, you can just go in and collect data, right? And that's the fun part with a lot of capstone consultant projects, not during COVID, but in other situations, and we were still doing some. I think we have at least 2 projects that are doing a data collection. FN America and Siemens, I think they are in their plants and collecting data there with all the kind of safety and regulations that we need nowadays. But it's a lot of fun for the students to go, right? I had students go in a hospital and staying a lot of time with different areas, different departments. I had students go inside the truck for that, a delivering route a project with Atrium Healthcare. The students were actually in the truck with the truck drivers and seeing them delivering things in the different hospitals and the problems that they face. They were following the people delivering the equipment, the cleaning equipment project that I also talked to you guys about in another video. I have students inside a train, actually. We have a company called Alpac Polyester, which is 70% of what they do is train deliveries, and we have students inside the train to actually look at their movements inside the plant. So a lot of cool stuff happened. The Textron plant with the golf carts, we did a lot as well.